This morning I'd like to make sure that you can distinguish between correlation and causality. I want you to look up in your exercise books the answers you gave to question 3A of the previous exercise. If you gave one, if you didn't, you really need to know how to. The last exercise was about r squared, 2c, and at the end of the exercise there was this question 3 on the board. So you may not be able to read all of it, but you should know what it says. 3A says, for each of the following, determine 3 things. Coefficient of determination, which is r squared. Writing it as a percentage, multiplying it by 100 in other words. And the interpretation. Now, I just want to review all those 3 things. 3A, we've got a value for r. What do we do with that to find out what r squared is? What would r squared be if that's the r that you're given? Negative times negative is positive, so it's positive. What was the answer again? 373. So r squared equals 0.373. Okay, that's the first part of your answer to 3A. 3A part 2, they now want it as a percentage. By the way, that has to be 3 decimal places. How do we turn that into a percentage? 37.3%. All right. So that's the second part of the answer to 3A, writing it in percentage terms correct to 1 decimal place. And then interpret. Now, has anybody actually got down an answer which they've checked in the back to be roughly correct and would like to read it out? How do we interpret that? What you've got to do is write it in terms of hearing tests and age. 37.3% of scores in hearing tests can be explained by age. Now, that is where you're turning correlation into causality. What you're doing is you're saying 37.3% of the variation in scores is caused by age. And then, of course, that means that 63% of your scores in your hearing test is caused by something else. So that correlation, yes, there's a correlation, it's moderate or whatever, 37.3. So this is where we're up to now. The first important thing to note is that, which I think we've already established, correlation does not imply causality. Sometimes we've got a correlation where there was no causality at all. Your score in English does not cause your score in maths. They go up because they're both caused by your ability or your intelligence or your environment or whatever. How do you establish causality is what we're looking at first of all. The point about causality is you need to conduct a controlled experiment to prove it. And that is not always on. For instance, I might want to decide whether my teaching causes any change in your ability to do tests. So I might give half of you the lesson and half of you not give the lesson, and then give you the test. And lo and behold, I've caused the change in your ability to do well in the test by not giving you the lesson. So you need to do that sort of thing if you're going to establish causality. You need to conduct a controlled experiment. The trouble is you can't. I mean, I can't give half of you the lesson only. Ethically, you can't do it. If you want to establish whether smoking causes lung cancer, you don't force half the population to smoke and the other half not to smoke. It will never happen. So you can't prove causality very easily. However, you do have to have an experiment. Anyway, that's just a piece of information that is about what science is like in general. If you're going to prove anything, you've got to conduct controlled experiments. And if you are going to conduct controlled experiments, these are the 3 things that are coming up in this course this morning. There are what we call common cause variables, confounding variables, and coincidence variables, and we're going to look at each of those. In other words, remember the one we looked at just now, 37% of your score only is, hearing score is caused. There may be other causes, and we need to establish what they are. All right, so going into them in more detail. First one, common response. Did I write common response on that previous slide? Yeah, common cause, common response. Look at this one here. Someone has said there is an observed association between the use of sunscreen on the beach and fainting on the beach. They said, oh, look, more people, as we count how many people who have sunscreen, on a particular temperature, it goes up. How many people have fainting when the temperature goes up? And somebody might say, is there a cause between some people might say there's a connection between the use of sunscreen and fainting. They've observed that they both go up together, but in fact the reason why they're going up is there's something called a common cause. They're both being caused by the rise in temperature. So temperature causes an increase in use of sunscreen. Temperature causes an increase in fainting. So just be careful. Sometimes you'll get questions where you're given two things which are going up together. Why are they going up together? It's because they've got a common cause. Something else is making them both go up. So that's an example of the first of the three types of non-causal explanations of an association. We've had plenty before, but now we're putting it into this language. All right, second one is what they call confounding variables. Confounding means mixing up, muddling up. And in this case, there's an observed association between the amount of unemployment and the amount of crime in a town. Unemployment rates could cause crime. If there's more unemployment, there might be more crime, agreed? Yeah. But also the economy, the state of the economy obviously has an effect on unemployment, and the state of the economy has an effect on the amount of crime. So a completely different explanatory variable may be the cause of the RV. There certainly is an association between unemployment and crime, but again, is that really the main cause for the rise in crime? So that's confounding variables. That's something else you need to be able to identify. That's two of them. See the difference between those two? Difficult to see at first, but that's the difference between that one and common cause is that in the first one, there's absolutely no connection, no cause between sunscreen and fainting, whereas in here there may be. So you've got to be careful what you're saying is causing what. This is the problem that statisticians have with using this information and analysing it. Third one is easy to understand, coincidence. There's no diagram for this one, but it says there's a high correlation between the amount of margarine that people eat and the divorce rates. Nevertheless, there's no common cause or there's no confounding variables. It's just a frigging coincidence if it happens. So those are the three things you've got to be looking for when you're looking at examples and asked to explain the cause. All right, so those are the three. They all begin with C. Write them down in your notes on your cheat sheets or whatever when you come to a test. You won't be tested on this until the semester test because you've got an assignment on this. Now what we're going to do next, before we do the exercise, may not even have time for the exercise today, I'm going to run through a video which is about smoking and lung cancer. The reason I'm doing that now is because they use all the language I've just been using. They talk about confounding variables, common cause variables, coincidence variables. It goes right back to the beginning of the whole debate about smoking. It goes back to the First World War when people started smoking heavily for the first time, and through to the time when they started to realise there seems to be some connection, but they couldn't prove a connection, and the tobacco companies were against people trying to prove it, until eventually we get to the point now where no one questions it.